Hey everyone, thank you so much for joining us today. We'll give it a couple minutes or so to get started with our today's session. Let us know in the meantime where you're joining us from today, and if you're already aware about Hudi or Lakehouse projects in general, let us know about that as well. All right, I think we're good to go. Once again, welcome everyone to the episode 3 of Lakehouse Chronicles with Apache Hudi. With this new series that we started a few months back, we want to focus on everything Apache Hudi and how it enables an open Lakehouse architecture. Usually, we have discussions on critical topics, go over some of the architecture internals. Most importantly, do some show and tell, the demos of getting started with Hudi, how to implement certain use cases, interviews with PMC members, and so many other things that we are planning to do again next year and this year with this new series. Overall, the idea is to make things easier for developers and users to get started and use Hudi in their workload. So, irrespective of if you're an already experienced Hudi user or contributor, or someone who is completely new to the entire space of Lakehouse and specifically Apache Hudi, you should be able to find a lot of beneficial content over here. We will also have a recorded version for this particular session. So, in case you are not able to make to the live session, feel free to watch it later in YouTube. And for this specific session, we will take any questions that you might have asynchronously, which means you can post it on our LinkedIn events page that basically presents the event, and we will get back to them later with both me and the speaker. All right. So with that, let's introduce our speaker, Soumil Shah. Soumil is a senior software engineer at Zeta, and Soumil probably needs no introduction. He has been an active contributor to the Hudi community with a lot of content on Hudi and AWS, and helped a lot of people in implementing use cases such as the one that we will see today in action. So thank you so much once again, Soumil, for joining us, and over to you for your part.
Thank you so much, Dipankar, and thank you, Apache Hudi community, for giving me this wonderful opportunity. First of all, good morning, good evening, and good afternoon to all the people who are tuning in from different time zone. Thank you so much for joining in today. So in today's workshop, we are going to learn how to use Hudi Streamer to ingest data from an operational database such as Postgres. We're gonna be capturing those CDC events into Kafka and then ingesting into Hudi via Hudi Delta Streamer or Hudi Streamer. This lab also focuses on using and configuring Hudi multi-table Delta Streamer. Hudi multi-table Delta Streamer allows you to ingest data from multiple Kafka topics into Hudi in a structured and a streamlined approach. So before we begin the today's workshop, I do want to cover a little bit about theory on Apache Hudi Streamer, what it is. So let's talk about first what is Apache Hudi Streamer. Apache Hudi Streamer is a utility provided by Apache Hudi which simplifies data ingestion from various sources into Hudi transactional data lake in a structured and a streamlined approach. So Apache Hudi Streamer supports ingestion from data sources such as Parquet files, CSV files, JSON files. You can ingest data from Kafka topics in a streaming or a batch-oriented manner. This supports both of them, Avro messages and JSON messages. You can ingest data from Apache Pulsar topics, right? That's also possible. You can also run incremental pipelines using the Hudi Streamer. Hudi Streamer also allows you to transform the incoming data using a SQL-based transformer. Hudi Streamer also allows you to connect to any JDBC source and pull data in an incremental fashion using Hudi JDBC based puller. Hudi Streamer also takes care of checkpointing. So in simple words, Hudi Streamer is a tool that simplifies the data ingestion from various sources into Hudi transactional data lake. So now that you have a good understanding of what Apache Hudi Streamer is, now let's focus on a small workshop. So I'm gonna share my screen. Hopefully you guys can see my screen now. First, I will cover the project repository, the project directory, and then we'll dive into the code. So this project repository will contain a docker compose.yml file. This docker compose.yml will spin up our infrastructure. It will spin up a min.io container, as you can see over here. It's gonna spin up Hive as a metastore. It's gonna spin up a Trino. It's gonna also spin up Zookeeper, Kafka, and schema registry. So all the infrastructure would be spinned up using this particular docker compose file. After that, you have a folder called Trino. Inside the folder Trino, you would have notebooks, which has a IPython notebook where we learn how to query our Hudi tables. Inside etc, we have a folder called catalog, and then inside there we have hudi.properties. So this allows Trino to connect to the Hudi. Then all the code and the materials regarding Hudi Streamer would sit inside the folder called Streamer. Inside the Streamer, you will have a config folder and some property files, which we will cover shortly. And then you have a folder called Spark properties, where we define Spark settings, right? Then we have SQL scripts. These are the scripts which will create tables on Postgres, and then we'll learn how to ingest those data from Postgres into Hudi, right? So that's that. The jar folder contains the jar file for the Hudi Streamer. The folder Debezium contains two files, customer.properties and order.properties. This will be used when we go to the Kafka Connect and deploy our Debezium connector to ingest data from Postgres into a Kafka topic, right? So those are over here, okay? So the first step that we want to do is we want to come to the project repository. So I will copy the path, and then I will increase the font size so it's visible. So I am inside the directory, as you can see, ls-l, and then here I have my docker compose.yml file. So we're going to spin up the infrastructure first. So we're going to say docker compose up --build -t. So this will spin up all the containers locally. So let's give it a couple of seconds. Once the containers are up and running, we are going to take a look at the next particular steps. So my Docker containers are finally in the started state, right? So great. You can also verify that by Docker desktop. So if you open up your Docker desktop, you will see all the containers should be up and running. So I have 6 containers and all the 6 containers are in the running state. Once the containers are running, let's verify if everything is created successfully. So first we will head over to localhost 9000. This is where our min.io object store resides. It's similar to S3, right? And the username will be admin and the password would be password. Click on login. You should see a bucket called warehouse where we will build our Hudi transactional data lake. After that, let's go to localhost 8080. This is where our Trino would sit, right? So if we put in the username as admin, here you can see the Trino cluster. And then we're going to verify by going to localhost 3040. Here we should be able to see our schema registry, Kafka topics, Kafka Connect UI, and all the other important relevant information. So since our containers are up and running, we need to install few dependencies. We would need PySpark version 3.4.0, and you can simply install that by a pip command, pip3 install PySpark is equal to 3.4.0. And after that, we also need to install Java 11, and we need to do that with the following command, brew install openjdk@11, and this will install openjdk version 11 on your machine. All right, so now we are going to head over to localhost 3040, and we will click on the connectors, Kafka Connect UI over here. We'll click on new, and then here, over here, we're gonna search for Postgres. And then here we are going to paste the properties. Before that, I will open pgadmin. It's a client tool that will allow you to query your Postgres data. I will refresh this since my containers are up and running. If you go inside the metastore, schemas, and then inside tables, here you will see customer and the order table over here. So let's run a simple query to see if the data is there. As you can see, there is some preloaded data about 4 customers in this particular table. And then we have about, I believe, 8 order items in the order table, as you can see. So we have some data that we can play with. Now we need to learn how to use Debezium and grab the CDC events from Postgres into Kafka. So now we will head over to the folder Debezium. We'll head over to customer.properties. I will walk you over the settings shortly. And then we're gonna paste them over here. I will zoom in. I'm just giving it a connector name over here, right? The connector class, we're gonna be using io.debezium.connector.postgresql.postgresql connector. After that, the database username is gonna be Hive. The database name is Metastore. That's the name of the database. The password is gonna be Hive. Okay. We are interested to get data for the table customers, which is in the public schema. And this one right here is important. We need to set tombstone on delete to false. Once we do this, so I'm gonna click on create. Now here you can see it is creating that. Now, once that is done, open up a new tab, head over to localhost 3040, head over to Kafka topics, and then try searching for, let me zoom in, customers. So here you can see, we should see hive.public.customers, and here you can see we have the data. So if I simply switch to the table view, here you can see all the data that we had in Postgres, we have that in the Kafka topic. And if you make any modification, those changes will be captured into Kafka. Now we'll do similarly for the orders. So I have orders.property. Again, I will head over to localhost 3040. Gonna click on new. Search for Postgres. Similarly, I'm gonna name this as Postgres connector orders. You can name it whatever you like. The database name, the password, the particular table that we are interested in, and then we set tombstone on delete to false. And I will click on create. So we have 2 of them. And now if I head over to the topics, I refresh my console. And now if I search for orders, I can see hive.public.orders. And this should, and here you can see Avro, meaning these are Avro messages. Okay. So if I click on this particular topic, in a particular second, the messages should be loaded over here. As you can see, we have all the messages over here. Great, congratulations. So right now what you have done is we have used Debezium, and we are listening to the CDC events from Postgres, and now we are capturing them into the Kafka topic. So we have Avro messages there. Now we will learn how to use the Hudi Streamer and ingest data from these topics. Okay, sharing my screen again. So now for this, we are going to be leveraging Apache Hudi multi-table delta streamer, which allows you to ingest data from multiple Kafka topics in a structured and a streamlined approach. So the way we will start is we have the folder called streamer. Inside that we have config folder. I'm going to expand that. Here you will see 3 files, and I will tell you how to name these files. So first we are going to go to source.properties. So I will expand this. Here you can see hudi.streamer.ingestion.table to be ingested. Here I want to ingest 2 tables, which is customer and orders. Again, you can add more tables, which is basically more topics separated by comma over here. And here you can see these are the path to that config file. So Hudi Streamer ingestion customers.config file. And here I am specifying the path to the config file. Similarly for the orders, I'm saying hudi.streamer.ingestion.orders.config file and the path to the config file, right? So these 2 config right here tells the Hudi Streamer for this particular topic where to find the Hudi configuration for that, right? And then all the common configuration are listed over here. For example, the Bootstrap server, the Kafka Bootstrap server is on localhost 7092. The schema registry is on 8081. And we are going to be using the following class for deserializing messages. io.confluent.kafka.serializer.kafka avro deserializer. Because we are ingesting avro messages, we are using Kafka avro deserializer. These are some of the common configurations for Hive sync. Once the data is written to our object store, Hudi will sync the metadata to the Hive metastore. And here is the Hive metastore URI. And the sync mode will be set to HMS over here. Now let's take a look at these configs one by one. So if we go to default_customer config.properties. So I will zoom out. Over here we define the record key, which is the primary key of the Hudi table. I would want to partition my Hudi table by state. Among the incoming records, I will be using _event_origin_ts_millisecond. This is a timestamp which will be used for deduping purposes. Precom key in Apache Hudi, whenever you have a group of incoming messages, Apache Hudi will use this particular field to determine which is the latest record. We are ingesting data from this particular Kafka topic, hive.public.customer, right? The offset is set to earliest, right? We are using the metadata. I have set metadata to true, and I've also set Hudi metadata index async to true, so that we can build indexes in an asynchronous fashion if needed, right? And these are the settings for the Hive. So here the Hive database is gonna be default, and the table name is gonna be customers. Similarly, we have orders. If I zoom out, absolutely same settings. We define the record key, we define the partition path, we define the dedupe key, we define the Kafka topic, and some common configs, right? So to sum up again, we have source.properties, right? The source.properties, you will specify the topics or the tables that you want to ingest in the Hudi data lake. Here I'm showing you customer and orders. You can simply add more needed by separating that by comma. And then you will, for each particular table, you have to provide the path to the config file where Hudi can find the configuration, right? And all the common configuration goes on the bottom section over here. Now we are going to take a look at Spark config.properties. This is where we define settings related to Spark, such as the Spark serializer. We're going to set that to cryo serializer. Then we basically set up our min.io access secret and the endpoint. And then the Spark catalog is set to Hive over here, as you can see. And now we're going to take a look at the job. So let me collapse here. So Spark submit. The class we are going to be using org.apache.hudi.utilities.delta-streamer.hudi multi-table delta streamer. Again, multi-table delta streamer is much better. It allows you to ingest data from multiple Kafka topics into Hudi in a streamlined approach, right? These are the packages that I'm going to be using. I would need the Hudi Spark package and the AWS Hadoop package, right? This is the part to my Spark property file, as you can see. Please make sure to change the path depending upon where you're storing it, right? This is the jar file. We are using the following jar file: Hudi, utility, slim, bundle, and then we're using 0.14.0. Operation is set to upsert. So I want to run the Hudi Streamer in upsert mode. I want to enable Hive sync. The table type is going to be copy on write. Hudi supports merge on read and copy on write. And then we are using the event origin timestamp for dedupe purposes. And these are important. So the source class, we are going to be using org.apache.hudi.utilities.sources.debezium.postgres Debezium source. This is used for Debezium Postgres source. Similarly, that is available for MySQL as well, right? And then here we are using the payload class, the target table, which is customers and order, right? This is the path on our min.io where these tables are going to be created. And then we need to provide the path to the config folder and the property file. So the property file is your main property file, source.property, right? So if I go to source.property, this is the one over here. This tells Hudi that, hey, it needs to ingest these two tables, and these are the configs where it can find that, and these are the common configuration, right? And the property file is the folder. It points to the folder where Hudi can find configuration related to individual tables or topics that you want to ingest, right? All right, so now that makes sense. I will simply copy the Spark submit. Here you can see I have my terminal. Let's head over to Minayo. I do not have any data over here. I will paste the command over here. And now, as you can see, my Hudi Streamer is running, and it is ingesting data from my Kafka topic into our Minayo. This will take about a couple of seconds. So let's be a little patient and see once the job is complete. In the meantime, I can probably, I think the job is complete. I will refresh. Here you can see on Minayo, I see a Hudi folder. I see the database default, and I see two tables, customers and orders. As you can see, customer, here you can see these are the partition. This is the Hudi metadata. And similarly, we have the order table over here, right? And the Hudi metadata for that particular table, right? Pretty straightforward, right? So now we have ingested data. Now let's see if we can probably run the query from Trino. On my another terminal, I will open up Jupyter Notebook. So I will type the word Jupyter Notebook, and this will start the Jupyter Notebook. Let me simply refresh and then open the notebook. And you need to install these two dependencies, Trino and IPython SQL, right? So now I will, select my Hudi catalog, and I'm gonna do show tables inside that. Here you can see, I can see my customer and order tables. Fantastic. I can do a select query from Trino, and I can see 4 customers and their appropriate email address. And I can do similar for the orders table over here. Great, right? Now the next part we're gonna see is we're gonna update some data in Postgres, and we will see our Hudi tables are also updated at the same time, okay? I'm heading over to Postgres. I will go to the table customers, and here, if you can see, email address travis61@example.org. I'm gonna change that to ****. I'm gonna click on OK, and then I'm gonna update this record on the database. Once I click update, as I click update, the event is captured by Debezium, and it flows into the Kafka topic. And now we're gonna run the Hudi Streamer again. I'm gonna run the Hudi Streamer again. And now those updates are captured and then will be updated on the Hudi transactional data lake. So the Hudi Streamer is running at this point, and I will probably go to my Jupyter Notebook. As you can see, I have already updated a record, and now I'm gonna query this table. Let's see. Here you can see that record has now been updated, right? So the moment I updated anything in Postgres, Debezium captured that event, it flew into the Kafka topic, and then our Hudi Streamer has ingested that into our transactional data lake. So I can see the latest changes over here. Fantastic. Now let's verify if deletes are working, right? So first I want to do a count on the order table. I have 8 records, and I will probably do the same on the Postgres. So select count from, I'm gonna do public.orders. And if I run this query right here, I should see about 8 records. So select count star from public.records. Let me, looks like I have a typo probably. Select count parentheses, and then I'm gonna say from public.orders. Public.orders does not exist. Let's see. Oh, it is orders. So I'm missing an S probably. And now let's query. We can see 8 records over here. So I was just missing an S. So now I have 8 records in Postgres, and what I'll do is I'll delete one of the records. As you can see, I have 8 items over here, right? I'm going to delete one of the records. Now, when I do that, that changes are captured, by Debezium. It flows into the Kafka topic. So I'm going to delete this. The record has been deleted. If I do the count again, I see 7 right here, right? Now I'm going to run my Hudi Streamer again. So it's going to fetch that new delta, and it's going to sync into our Hudi tables, right? So if I do select everything from orders, here you can see I have about 7 records. Now, once the ingestion is complete, which it is, and if I go to Trino and I'm going to run the same count query, remember we had 8 records, right? Now if I run, I should see about 7 records. Here you can see I have 7 records. So any changes that I make in Postgres are automatically synced with Hudi tables. If I delete something from Postgres, that is also synced with my Hudi tables. Great, right? So Apache Hudi Streamer does a lot of work under the hood. It takes care of checkpointing. It reads the message from Kafka topics. It deserializes the messages based on the schema, and then basically ingest that into the Hudi data lake. So fantastic. Our Postgres tables are now in sync with our Hudi tables. You can run the Hudi Delta Streamer in a continuous mode as well, and then specify the minimum sync interval, meaning after how many seconds the Delta Streamer should again sync or listen for new data, incoming data, right? You can absolutely do that. Now, one more component that I want to talk about is the indexes in Apache Hudi. Apache Hudi allows you to build a multimodal index. One of them is column stats and record level index. Record level index will speed up your point lookups, about 70 times faster point lookups based on some benchmarking. And column stat index will allow you to do data skipping as well. So let's take a look on how we can build a multimodal index with Apache Hudi. I have a simple command over here on my computer. So this one right here, as you can see, I'm using org.apache.hudi.utilities.hudi indexer. I just want to make sure I inform you, you can do table services and indexing in 2 modes. Either you can do it synchronously. After the writes have happened, Hudi will build the indexes, right? Or you could do it asynchronously based on all your workload. So in case if you have a streaming workload and you want to do this asynchronously, you can absolutely do that, okay? So over here, I'm using the class Hudi indexer, right? I'm using the appropriate packages and the jar file, as you can see. And then the mode, I'm using schedule and execute, right? And I'm doing it on the customer tables, right? And I'm building the column stat index. So if I copy this, before that, if I go to my customer Hudi table, if I go to the Hudi folder, if I go to metadata, again, I do not have a column stat index, right? So now I will fire the command, and this will build the column stat index for that particular table. So my queries are going to be much more efficient, right? It could do the data skipping. It is complete. Now, if I refresh, here you can see the column stats, right? So it was able to create that index for us, right? We are also going to create a record level index, and again, I'm going to use the same class called Hudi indexer, and then here the index type is going to be the record level index. Record level index are great for point lookups. It really speeds point lookup by about 70 times, right? So now I will again run the command, and once this is complete, in the background over here, and it's complete, and here now I can see the record index, right? So I just wanted to show you that you can build a multimodal index in Apache Hudi. Hudi also supports exporting data. So for example, if you have a Hudi data set and let's say your analyst or data scientist have asked for the orders data where the priority is high, maybe they want to train something, or maybe they want to do some analysis, right? You can use the Hudi exporter, right? And here I just wanted to show you that. Here, as you can see, this is the path to my Hudi table. And then here I'm saying that, hey, Hudi, I'm going to use the Hudi snapshot exporter service, and I want to get all the data where the priority of the orders is high, and then dump those files as a parquet on this particular directory. This directory does not exist on the S3 bucket, but once I run it, it's going to dump those files on S3. So if I run this one over here, if I probably go to min.io, it is complete. And if I refresh, here you can see exports Parquet, and then it was able to successfully, from that entire Hudi data set, it was able to grab all the orders where the priority is high. Now the analyst can go read the data, or maybe if any customer has asked for that particular data set, you can use the Hudi exporter utility and export data into JSON or Parquet files into whatever or whichever destination you want, right? So I hope you have enjoyed the workshop. All the materials would be there on the GitHub. I do want to cover two small blogs. Because of the time constraint, I cannot cover everything, but I do want to show you this benchmarking. So we created a Hudi record level index, right? Whenever you do a point lookups, as you can see, the record level index has outperformed, and it provides about 70 times faster point lookups, right? Not only that, the column stat index will allow you to do data skipping. For example, over here I'm saying give me all the records where salary is greater than this amount, right? Now I know that this record is not there in the Hudi, right? If you observe this particular screenshot without indexes, it has scanned over 50 files, right? But once you build the column stat index and now you run the same query, if you look at the Spark UI, number of files read is 0, right? So you see how indexes, in Apache Hudi helps you for faster queries and also faster upserts and point lookups. So thank you so much for joining for today's workshop. I hope you have enjoyed and found value in that. If you have any questions, I or Dipankar can answer if we have time right now, or we can take it offline.
Thank you so much, Soumil, for joining us today and showing us this awesome demo that people can take inspiration from and use it as a way to build their pipelines in production environments or in their own implementations. So really appreciate taking the time from your busy schedule and helping our community learn a little bit more about how they can use Hudi in their ecosystem. Also, thanks to all the people who took some time to join this particular session and episode. While we are here, come check out our pages, our social pages, follow us on LinkedIn, Twitter. There is also a QR code that I put it up here. You can use it for joining our Slack channel, which is a great place to learn about everything that's been happening in the community, and ask your questions if any doubts or any errors that you're doing. So yeah, thank you so much for joining us today, and we will see you in our next episode. Bye.